today we're going to find the approximate area of the region under 3 over x from x equals 1 to 5. So we call these Riemann sums, and I think we'll find the mid-Riemann sum first because it's the easiest to see what's happening. So if in pink we go up here and find the middle of each rectangle, its width is 1, but its height is whatever this is. And this is 3 over x. And if it's right in the middle of that interval, that's 3 over, well, x right here is 1.5. And so that equals 2. But you could see that from right here. So the area of this first one, it's 2 tall and 1 wide. So this has an area of 2. This next one, if we look right here, again, the width of this rectangle is 1, and its height is 3 over. X right here in the middle is 2.5. And 3 over 2.5 is 1.2. It's hard to tell that from the graph that this is exactly 1.2, but we can calculate it. And so this area is 1 times 1.2 is 1.2. So that's the area of the second one. Here's the middle of the third triangle. It's got a width of 1, and it's got a height of 3 over, well, right in the middle there is 3.5. So that means it's got a height of 0.8571. So this area is 1 times 0.8571, so that equals 0.8571. And then the last rectangle, right there, the point on the graph that's at the middle of the height of our rectangle, it's 1 wide, and it is 3 over 4.5 tall. And that is 0.6667. And so that's the area. So 0.6667 times 1 is the area of our last rectangle. And then we add all those up. And when you add all these together, you get 4 point, how many decimal places did they say? 3. So 4.724 square units, whatever they are. Now, I wanted to do the mid first because it's the most obvious. If we instead now, if instead we choose to go up the left side of each rectangle, then this rectangle, let me see if I can draw it with one of these. This rectangle, if we go up the left side and quit at the function, this rectangle is actually that tall. And so it still has a width of 1, but the height now, we're going up the left edge here. This height now is 3 over 1, which is 3. And if we go up the left edge of the second rectangle until we hit the function, notice we're going up until we hit the graph, the curve. Anyway, this one is 1 by Well, when x is 2, this is 3 over 2, this is 1.5. So this height here is at 3 over 2. So we're going to add 1.5 here. Then we go up the left side of the next rectangle and stop when we get to the function. So this one, the function's at 1. So this is 3. Well, the value is 1. 3 over 3, because x is 3, we get 1. So the area of this is 1 by 1, which is 1. And then the last one, we go up the left edge of the rectangle and stop at the function. And at x equals 4, this height is 3/4, 3 over 4. So that means we're going to add 0.75. Now, when you add all of these, you get a different number than when you did it in the middle. This number should be an overestimate because notice all of our rectangles are taller than our function. So 3 plus 1.5 plus 1 plus 0.75. This, if we looked at just the left rectangles, we would think that the area was 6.25. Now, let's do it again, but let's go up each one of these rectangles on the right side. So I'm going to be here at 2 and stop at the function and draw your rectangle back. Well, this has a base of 1 and a height. We went up at 2 here, so 3 over 2. This is 1.5. Then if I go up the right side and stop at the function and then go back, this height is 3 over 3, which is 1. So 1 times 1 is an area of 1. If I go up the right side of this rectangle and stop at the function and then draw my rectangle back, this has a height of, we're going up at 4, so 3 over 4 is 0.75. And then the last the last rectangle, we're going to go up the right edge of this rectangle, stop at the function, and draw it across. So this one, 3 over 5 is 0.6 times 1 is 0.6. Now, this one is going to be an underestimate because all of our blue right rectangles fall below the curve. So when we add up 1.5 and 1 and 0.75 and 0.6, I should make this clearer. That's a 0. We get 3.85. So as you would expect, the left Riemann sum is an overestimate. It's the highest estimate. The right Riemann sum is an underestimate. It's the lowest number. And the mid Riemann sum is in between these. And if you really want to know the actual, it's going to be, I better figure that out before I tell you. So we'll just stop here. And I'm not sure which of these approximations your teacher wants you to use, but, or maybe all 3. Wait, I can tell you the actual. We're going to integrate 3 over x from 1 to 5. And the actual area under that curve is 4.828. So clearly the mid was the closest.